All right, so here we're just kind of do substitution basically. So we're using only the properties of logs and the approximation. So we're not using a calculator. We're just using this approximation, and this approximation to solve these three problems. All right, so what is ln of 81? Well, 81 is what? 3 to the fourth. Okay, no problem. Well, what do we know about our property of logs? We can bring that 4 down in front. So if we have 4 ln of 3, well, guess what? ln of 3 is 1.1, so we have 4 times 1.1, which is 4.4. So this is how they're wanting us to do it instead of just typing in ln of 81 and getting 4.4 rounded to the nearest tenth and going from there. All right, what about the next one? ln of 10. Well, 10 is what? 2 times 5. So we have ln of 2 times 5. We split that apart using a product rule. That's ln of 2 plus the ln of 5. And so it's going to be zero point 0.5 or zero point 0.7 plus 1.6. That gives us approximately 2.3. And finally, ln of 6 fifths. And so we're going to have ln of 6 minus the ln of 5. But 6 we can break apart into 2 and 3. So we're going to have ln of 2 plus ln of 3 minus the ln of 5. So now we just take that one plus that one minus that one, and we end up with zero point 0.2 as our example or as our problem. Now see, really, at this point we could say, well, this was really ln of 6 minus ln of 5, but then we don't have an ln of 6 up here. So then at that point we could say, okay, well, that's ln of 2 plus ln of 3. And so we could have done that. So sometimes it's easier to, start with what you can do easy, and then after that move on and break things apart further until you have the final thing. Sometimes it's hard to think about what this is. Sometimes it's easier to say, okay, let's just use a quotient rule, ln of 6 minus ln of 5. Now ln of 6 is ln of 2 times 3, so that's ln of 2 plus ln of 3. All right, so one of the most important formulas here we can do is called the change of base formulas. And the reason I say that is because the majority of our calculators cannot do anything other than E or 10 as your base. Now, some of the actual cheaper calculators will do different bases, but if you have one of the high dollar graphing calculators, it doesn't do that. So we need to have this change of base formula. So basically, log base A of x is going to be the log of the x over the log of the A. And now we can use log log or we can use ln log. For some reason, I always use ln log again because if I'm going to write it, I want to write less. And so writing log and then log, that gets a little tedious, but just ln x and ln a is going to be the same. Both of them are just going to be one keystroke on your calculator. You either hit log or you hit the ln, and it's going to give you the same answer. So here we're supposed to approximate log of base 7 of 56 to the nearest thousandth. So we just take log 56 divided by log of 7. And again, you can use ln or you can use log. Both of them give you the same answer. And test it out on your own calculator and you'll see that they do give you the same answers here. All right, so hopefully that gets you started on this section.